This slide offers another view on the scenario. In the upper part, welcome to the module Key Features PSS Family. Upon completion of this module, you should be able to identify the 1830 PSS portfolio, explain an overview of the main features and architectures. Here is the table of contents. You can click on a title to navigate to a specific topic. From any content slide, you can return to the table of contents using the rounded button labeled TOC in the bottom right corner of the slide. Let's discuss the 1830 PSS family. Generally, the Nokia 1830 PSS portfolio can be subdivided into different areas. The premises and access part, including front haul, the metro part, and the core. For each of these areas, Nokia offers a range of products, which are mentioned in this slide. In the premises area, there are 1830 ONE, 1830 Wavelight, 1830 PSD, and 1830 PSS4 used for access, and 1830 VWM for front haul services. For the metro area, there are 1830 PSS8, 1830 PSS8X, 1830 PSS16-2, and the 1830 PSI-2T, serving for the next generation of metro and data center interconnection applications. For metro and core area, Nokia provides 1830 PSS32, 1830 PSS36, 1830 PSS64, 1830 PSS8X, and 1830 PSS24X. Nevertheless, the borders between these areas are fluent, so that a metro system might be found in the access area or a core system in the metro area. This slide offers another view on the scenario. In the upper part, there is a map of a typical network consisting of core routers, service routers in the metro area, and NEs for the different applications in the access. Nokia offers scalable product size variants from access, 1830 PSS4 to core, 1830 PSS64. Part of the last mile access are 1830 ONE, 1830 VMN, 1830 Wavelight, 1830 PSD, and 1830 PSS4. In the access area, lower data rates are in use. These are provided by ODU1 and ODU2. In the metro area, we find systems like PSS8, 8X, 16, and 16.2. Furthermore, PSS32, 36, 64, and 24X belong to the core area. Usually, one deals in both metro and core area with higher data rates provided by ODU3 and ODU4. Please keep in mind that the borders between access, metro, and core are fluent, so it might be that some systems can be part of two of these areas. Let's discuss the 1830 PSS features overview. The 1830 PSS photonic system consists of several shelf types that can be configured with multiple shelf scenarios. On this slide, several key functions are shown. 1830 PSS shelves provide 8-channel CWDM and up to 96-channel DWDM functions. Tunable and pluggable optical transponders, or OT, and muxponders are available. Interfaces are scalable. Multi-service and any-rate cards offer a wide range of interfaces. These are configurable through software. The main protection schemes supported by 1830 PSS are optical multiplexer section protection, or OMSP, optical physical section protection, or OPS, client-side OPS, electrical subblock network connection protection, or ESNCP, ODUK subblock network connection protection, or SNCP, optical subblock network connection protection, or OSNCP, and OPS-based 1+1 OCH protection on 100G OTs. The 1830 PSS supports point-to-point, ring, and mesh configurations. The available planning tool and management system enable automated planning, commissioning, and operation using the wavelength tracker functionality. Wavelength tracker is a technology that applies a key to each individual optical channel so that it is tracked, monitored, and adjusted throughout the network. All configurations like fixed optical add-drop multiplexer, or FOTOM, reconfigurable optical add-drop multiplexer, or ROTOM, tunable optical add-drop multiplexer, or TOTEM, and CF, CD, CDCF are supported. The GMPLS control plane provides restoration mechanisms to ensure service resilience. It enables MRN in combination with the 1830 PSS optical cross-connect system, or OCS, shelves, and network resilience for protected or 1+1 SNCP and PRC services. The 1830 PSS can be configured into a number of architectures. The FOTOM arrangement uses static filters and tunable transponders. It is a low-cost solution if flexibility and automatic refibering are not needed. Colored add-drop capability with up to 2-degree or 4-degree configurations is possible. ROTOM configurations use wavelength router, or WR cards. They offer colored add-drop capability, automated commissioning, power control, and optical monitoring. iROTOM F and iROTOM V have been added as low-cost integrated Metro ROTOM cards. The TOTEM configuration is based on colorless wavelength routers, or CWR. These enable colorless add-drop capability when OTs are connected to the colorless ports. Otherwise, they have colored add-drop capability when OTs are connected to SFDs. Another configuration is ROTOM CDCF. This configuration is based on wavelength router 1x20 tunable FlexGrid module, or WR20 TFM, and other set of circuit packs, which we will cover later in this course. These enable colorless, directionless, and contentionless add-drop capability. With tunable transponders, any wavelength can be dropped and the transponder will adapt to that wavelength. The 1830 PSS family consists of two different NE types, the SWDM-NE and the OCS-NE. The SWDM-NE supports WDM and switching. Examples for an SWDM-NE are PSS-8, PSS-16, PSS-16-2, and PSS-32, representing the WDM functionality. On the other hand, PSS-8X and PSS-24X are SWDM-NEs, providing the switching functionality. All SWDM-NEs have a similar web-based user interface. The second NE type is the OCS-NE, which supports primarily the switching functionality. OCS-NEs are PSS-36 and PSS-64. This diagram explains an OCS system. The TDM switching is performed by an agnostic matrix. The agnostic matrix switches client port to client port, or client port to uplink card. Client cards provide Ethernet, SDH, SONET, and OTN interfaces, while uplink cards provide OTN interfaces. This is the working principle of an OCS NE like PSS36 or PSS64. On the other hand, some SWDM systems like PSS8X or PSS24X operate in the same way. To extend the capacity of a single 1830 PSS node, it is possible to form a network element consisting of a master shelf and a number of extension shelves. This page shows an OCS NE as an example. The master shelf of an NE has a public IP address and is attached to management communication via OAM port. In larger applications, an NE with extension shelves saves a huge number of IP addresses. The OCS NE can consist of one master shelf and up to 7 expansion shelves. All shelf types are PSS36 or PSS64. The LAN cabling distance between the NE shelves is limited to 100 meters or 300 foot. An SWDM NE provides two functionalities. First, it contains photonic routing and switching, which is the WDM functionality. This diagram shows the WDM switching in view of a 2-degree ROADM. The incoming optical signal will be amplified by a line driver, passes a multiplexer or demultiplexer, and will be switched by a wavelength selective switch. This functionality is provided by SWDM systems like PSS8, PSS16, PSS16-2, and PSS32. The second functionality of an SWDM is also shown in the diagram. It is the TDM switching, which was explained as an OCS functionality before. PSS8X and PSS24X are SWDM NEs which support the TDM switching functionality. The SWDM NE can consist of one master shelf and up to 23 expansion shelves. Each SWDM NE can include PSS24X as a master or an extension. Each SWDM NE supports an IP address and L1 GMPLS for 24X or L0 GMPLS on its master. The SWDM is always the PSS8, PSS16-2, PSS32, PSS24X, PSS16, and PSS8X. As shown, it can be extended by other SWDM shelves. The size of an SWDM NE depends on the shelf type and on its role in a cluster. Detailed information are given on the following slides. A cluster is a set of these NEs that are connected with each other so that NEs in the cluster can manage OTs coming from other NEs. The cluster is hierarchical, with one NE being master and all others being slaves. SWDM NE is the main NE of a cluster. Other NEs are tributary NEs. A cluster may be composed of one or more OCS NEs, up to 3, one or more SWD. How many extension shelves can be configured as an extension shelf to an SWDM master in detail? This depends on two parameters: the SWDM shelf type, and on the other hand, its role in a cluster main, or tributary NE. In this case, the SWDM-NE acts as main cluster NE, and PSS8, PSS16-2, PSS24X, and PSS32 with 32EC2 are allowed to act as a master shelf. The other SWDM shelf types, such as PSS16, PSS32 with EC, PSS8X, can run as extension shelves only. This table is valid if the SWDM-NE acts as a tributary cluster NE. In the addition to the case before, PSS16 and PSS32 are allowed to run as a master shelf. Let's quickly recap what we learned in this module. In this module, we have covered the following items. Identify the 1830 PSS portfolio. Explain an overview of the main features and architectures.